All right, welcome back once again. We're going to employ our area models again for the third version of what we can do with them, which involves factoring. Factoring is breaking something up into a multiplication problem, so that's very close to division, and it's breaking it into a multiplication problem, so that's involved in there as well. So what we have here is x cubed minus 10x squared plus 17x plus 28. We did problems like this in the quadratic as well, and we had kind of some tricks to do that there. There are some tricks that unfortunately this year we don't have time to look into. They're not nearly as good a tricks as they are with the quadratic, but we are going to employ the technology to give us some clues here. So if we think in terms of the zero product property, which is what we're trying to get this thing to do, we're trying to get it to look like things multiplied together that when we set equal to 0 would find these points for us. Okay? Well, that point to me looks fairly close to 4, which means that an x minus 4 would make sense as one of the factors. And so I'm going to check to see if the x minus 4 is one of the factors by trying to divide x minus 4 out of this thing. Okay, so now this should be looking very familiar. The x cubed is there, and I'm just going to divide it and see if I get no remainder. If I get no remainder, then I'm in a good place. So that must be an x squared, negative 4x squared. I was supposed to end up with negative 10x squared, so that must be a negative 6x squared, which means this must be a negative 6x, which makes this a positive 24x. But this was supposed to be a 17x, which means that I must need, 7 more? 7x, no, minus 7. Okay. Get rid of that. So 24 minus 7x will give me 17x, but then this must be a minus 7, and that would make this a plus 28, which is exactly what I wanted. So far I've got this factored into an x minus 4 times an x squared minus 6x minus 7. And now I'm going to try and attempt to completely factor. I'm going to factor this part. I'll go back as a reminder on my area models and the nice tricks we had there. This was going to be an x squared. This is going to be the minus 7. We know that we need two numbers that are multiplied together to give us negative 7 and add to give us negative 6. That seems like a negative multiplied it, yeah. So a negative 7 and a positive 1 will do that. So these go in my boxes. I got a minus 7x and I have a plus 1x. And so shift colors here. If that's an x and that's an x, then this would have to be a plus 1, and that would have to be a minus 7, and the minus 7 plus 1 makes a minus 7, and that works out. So my final answer, I have the x minus 4 that I pulled out. I've got an x plus 1 and an x minus 7. So this is the factored form of that degree 3 expression that we had before. Let's do another example. Okay. So this one, I've got a lot of little things going on here, and they don't look like they're necessarily hitting in very nice places. So I might have to do some experimentation here a little bit. The one that I'm going to focus on is this one that looks to me, and I could have on a graphing calculator, might be able to zoom in better than that, but that looks like it's maybe hitting at negative 1/2. So that would mean x plus 1/2 might have been a factor of that. And I could certainly try to do that with fraction, but I could also say, well, 2x plus 1, if I multiply both of those by 2, 2x plus 1 would also make me go at negative 1/2, and since my leading coefficient here isn't just a 1, I'm going to try dividing a 2x plus 1 out of this first. So I'll put my 2x plus 1, start my box, and the 12x cubed will go in there, which would make this a 6x squared, and this a 6x squared, and I'm supposed to end up with a negative 40x squared, and if that's going to be a negative 40x squared, then this must be a negative 46x squared right there, which would make this a negative 23x. Shift colors earlier than that, sorry. Which would make this a negative 23x. So these are supposed to add up to positive 19x. And if that's going to add up to a positive 19x, then I would have to be 23 plus 19 is 42. And that would have to be a 42x. 42 minus 23 should be 19, which would make this a plus 21. And that would make this a plus 21, which it was supposed to. So far what I've got is a 2x plus 1. Okay, I got that pulled out of there. I'll put it in blue because I went in blue before. And that's times 6x squared minus 23x plus 21. Really the goal of this is get it down to things that are quadratic, because we got all kinds of tools that we can use once we have it in the quadratic form. So I'll employ my quadratic tools again. 6x squared, and that's a 21, and that's 126. So I'm looking for numbers that will multiply together to give me 126. And when I add them, I get a negative 23. It's indicating to me that they probably should both be negative numbers. What kind of numbers do I multiply together to get 126? Well, judging from here, there's some 2s, some 3s, some 3s, some 7 going on in there, and 9 and 14 looks like it's probably pretty good. So a negative 14 and a negative 9. So minus 14x minus 9x. My greatest common factor across the top here is a 2x, which would make this a 3x, which would make that a minus 3, and this a minus 7. Okay. And my other points here are seeing the about 1.5 makes sense, about 7/3, 2 1/3. That looks pretty good. And so my final factored form is a 2x plus 1 times one side of my box is a 2x minus 3, and the other side is a 3x minus 7. And so this is the factored form of that degree 3 polynomial expression that I had on there. Okay. Making note again, of course, as we've talked about, that the degree 3 and the factoring into 3 pieces, that's not a coincidence. Okay, that was sort of an expected thing. Obviously, first guess a little sketchy on this one. I did happen to make a good first guess, and it may feel like you're cheating a little bit to use the technology to come up with that in the first place. But the important part is that then we're coming back and we're verifying what we got from the technology and guaranteeing that it was the right thing to do.